Okay, our last question for this study guide is number 6, and it really is the heart of chapter 6. It's what we've spent the most time doing. We are given 4 different systems of equations, and we're asked to solve them using the given method. So I'm giving you the method. I'm asking you to use that method to solve that system. So for this first problem, A, we're asked to solve using substitution. And I can see quite clearly that the second equation tells me that y is equivalent to 2x plus 4. That's what y is. Well, what I'm going to do is I'm going to use that fact in the first equation to replace the y that's there. So I'm literally going to rewrite this first equation as 5x, okay, plus 5. And then instead of y, instead of this y, we're going to write 2x plus 4 because that expression, 2x plus 4, is the same as y. It's equivalent to y, and then that equals the number 50. So using the distributive property, I can multiply this 7 by both the 2x and the 4, and we will get that 5x is, or 5x plus, rather, 10x plus 20 is 50. Therefore, 15x, just combining the like terms, plus 20 is 50. 15x is 30. If we think about it, what did I do to both sides? I took away 20. And then finally, I'm going to divide both sides by 15, and I get that x is the number 2. So now that I have x is 2, I'm not finished because the solution to a system is an ordered pair. I need both an x and a y. So what I'm going to do is use this x value in this beautiful equation that tells me how to find y. It says to get y, you simply need to take 2 times whatever x is and add 4. Well, I know that x is 2 because I just found that down here. So I put a 2 in here. 2 times 2 is 4, so y is 8. So now I have my solution. My solution is x is the number 2, and y is the number 4. That literally is the place where these two equations meet if they were to be graphed on the Cartesian coordinate plane. And actually, let's jump to GeoGebra real quickly. So in GeoGebra, I can say I want to graph 5x plus 5y equals 50. And I also want to graph y is 2x plus 4. Okay, and those should meet when x is 2. 5x plus 5y. 5x plus 5y is 50. 5x plus 5y is 50. Y is 2x plus 4. I'm completely wrong. Oh, yeah, I am completely wrong. Because, oh, Mr. Roberts, that's so sad. When you look at this, right here, I wrote down y is 8. I sure did. I wrote y is 8. But what did I write over here when I wrote my ordered pair? I didn't write the 8. I wrote 4. So this is where these 2 points meet. Boy, it's a remarkable thing that I decided to graph that because I wasn't going to. But in graphing it, I realized I made a goofy error. So when I come back, I can see that, yeah, these 2 points meet absolutely when x is 2 and y is the number 8. And if I click on it, you can see these intersect at 2, 8. X is 2 and y is 8. Let's take a look at the next problem. So on the next one, we are asked to use by solving elimination. Now I know what you're thinking, and if you're not thinking it, you should. Most of the problems that we've looked at that involved elimination, the x or the y values just kind of magically disappeared, right? We didn't have to modify the equations often. And certainly I don't think you had to do that on your own. In class we did a few times, but you didn't have to do it on your own. So when I'm asking you to solve this by elimination, well, one thing I want you to know is if you really can't get going with elimination and you want to try a different method, that's okay. There might be a minor point deduction, but if you found the intersection, that would still be a significant accomplishment. But here's the strategy. If I want to solve this by using elimination, I need to get either my x's or my y coefficients so that they're opposites of each other. And if I think about this, I could multiply this top x by the number 3, and I can multiply the bottom one by -2. Now, if I did that, that would make the x coefficient in the top equation 6, and the x coefficient in the bottom equation -6. And 6 times x plus -6 times x would equal 0. The only problem I have is I can't just arbitrarily multiply one of my terms by 3. So what I would have to do is I would have to multiply this entire top equation through by 3 and the entire bottom equation through by the number -2. And if I did that, I would get a very nice set of equations that would work great with elimination. So this top equation is going to become 6x plus 12y equals 30. And you can see each one of those was multiplied by 3. The bottom equation is going to become -6x minus 6y equals -30. Oh, that's interesting. That's interesting. So if I combine these equations, right, if I take the equal things from the top equation, right, these things are equal, and I add the equal things, these things are equal, onto the bottom equation, I get a third equation that's equivalent to this system. And what I get is, first of all, the 6x and the -6x are gone. When I combine 12y and -6y, that's going to become a positive 6y. And over here, when I combine 30 and -30, that equals 0. And if I divide both sides of this by the number 6, 0 divided by 6 is 0. So y is the number 0. And if I take the top equation, right, it says 2x plus 4 times y equals 10, and I replace the y with 0, this equation becomes 2x is 10. Therefore, x is 5. And the exact same thing happens if I use the second equation as well. So my solution should be the point where x is the number 5 and y is the number 0. Now, I know what you're thinking. Mr. Roberts, given your record of getting things incorrect, right, wouldn't it be wise to graph that system in Geogebra to make sure that you have the correct solution? And I will. I could use Geogebra, but I could use Desmos as well. I think I'll use Geogebra. And up here, I'm just going to go ahead and type the top equation, which was 2x plus 4y. 2x plus 4y, doesn't 4y, and that equals 10. And my second equation is 3x plus 3y equals the number 15. And when you can see there it is, right? These 2 points are coming in and they're meeting at that location. That's the point where these 2 lines intersect. They intersect when x is 0 and y is 5. And you can see that's exactly what we got. We got that x was 0, and we got that y. X, I just said that backwards twice. We got x is 5 and y is 0. Yeah, x is 5. That's the first term, the first part of an ordered pair. X is 5 and y is 0. It must be nap time. Let's go on and do the next system of equations over here. It says, please solve this system using the equal values method. Most popular method at all the middle schools in towns. I think most of you have experience with this a lot. Certainly, it is true in the context of this system that y is equal to y. So what we do is we take that the top equation gives me one way to write y. This bottom equation gives me a second way to write y. So I can change this as 4x plus 8 is equal to -3x minus 27. Okay. So let's do this. To solve this equation, I'm going to add 3x to each side. If I add 3x to this side with a negative 3x, it's going to become 0. Over here, I'm going to have 7x. So this becomes 7x plus the number 8 is equal to negative 27. And now if I take this negative 27, on each side of this, I'm going to subtract 8. So if I have a negative 27 and I subtract another 8 from that, I get that this side is negative 35. So that means 7x is negative 35. And if I divide 35 by 7, I get that x is negative 5. And I'm definitely using a calculator, and it's perfectly fine to do that. So x is the number negative 5. Now that I know x is negative 5, I do need to figure out what y is. It turns out I have two ways to figure out y, right? Two different equations that tell me what y is. I'll use the top one. And it says that y will equal 4 times x, which we just found to be negative 5 plus 8. Didn't we? Was it negative 5? Yes. So 4 times negative 5 plus 8. 4 times negative 5 is negative 20. And if I take negative 20 and I add 8 to that, I'm going to get negative 12. So y is negative 12. So for this system, right, we have the solution where x is negative 5 and y is negative 12. And given my track record, again, it would be a wise thing to graph that system of equations. Let's do this one in Desmos. So in Desmos, here's Desmos for me. So in this, for Desmos, I'm going to type y is 4x plus 8. Enter. And the other one, oh, that's interesting. Can I fix that? There, that's still off the screen. That's no. I'm trying to get this. Okay, there. Now you can see. Now we can see all that. For the other equation was y is negative 3x minus 27. And, ooh, what? That's not y. Y equals, there we go. So I've got y is equal to 4x plus 8 and y equals negative 3x minus 27. Somewhere in here is a solution. There it is. Had to zoom out. Let me zoom in here. And if I click this spot, and it says, well, this happens when x is negative 5 and y is negative 12. That's where they meet. And you can see that that's exactly what we found. X was negative 5 and y was negative 12. The last problem here says, hey, solve this using any method you choose. For me, for this particular one, I just can't unsee the fact that this is equivalent to y. So I'm going to plug that into this second equation. If you choose a different method, that's okay. I'm going to use substitution. So I'm going to rewrite this as the second equation as 4x plus x plus 5, right? What I did is I just wrote y in there, and that equals 15. Therefore, 5x plus 5 is 15. 5x is 10, and x must be the number 2. And if x is 2, y must be 2 plus 5. Y must be 7. So my solution is at 2, 7. And I see no reason why I would want to go through and catch all my errors and not check this one too. So let's look at this in Desmos also. Y is x plus 5 is 1, and the other one is 4x plus y is 15. Oops, 15. And there we go, but I need to zoom out a lot. Okay, here's something, and zoom in, and I can see that I have found a solution right here where x is 2 and y is 7. That's exactly what we found, right? We found that x would be 2 and y would be 7. Another good way to think about checking answers to your work like this is you do have access to your TI calculator. So if I put this calculator up on the screen, here it is. this top equation tells me that if I take x and I add 5 to it, I should get y. Well, look, my x is 2. If I take 2 plus 7, I'm sorry. If I take, I'm being goofy. It says take your x value, okay, 2, add 5, and you should get what y is. Yeah, 2 plus 5 is 7. The other equation says that if you take 4 times x, so 4 times x, right, 4 times x plus y, you should get 15. And you can see that both of these equations were satisfied by this solution, right? Both of them worked when I plugged in the x and y. They both made true sentences. So this 0.27 is definitely a solution. All right, that's it. That's the last problem on the study guide.